Hi, this is Abdulaziz Khan, and in this video, if you have been watching my previous video, I was mentioning that I will discuss one interference report. Basically, a friend of mine he asked me to guide him about the report, so I thought that I should make a video so that it will help everyone. So this is a kind of report. Generally, like in my previous video, I ran some interferences and a report was generated. If you have selected one link and you have run an interference, you will have you can have many cases, but generally in we can say that you will have only one case because you have only one uh, radio, but you can have more than one cases as well. But for example, if you are running if you run a report of your network within the whole network. You said that give me a report between all links and all links. Then in that case, it will make a report between every link. So that can be a bigger report. Like for example, this report, it looks like to me that this is a kind of bigger report. Like for example, we can see that this is HRA 123. But for example, in this case, this is HRA 12081. This is HRA 12084. So a lot of links are being discussed. 123, then 223, 1 to 150, 2 to 4. So it shows that a person has selected many links and then it's a interference report between all those links. So because I don't have the network diagram, but it's not required. We can understand without that as well. But if we had a network diagram, then we could understand it much more that what kind of network it is, how much big it is, and but let us try to analyze. Because still we have something. So first thing first, we see that coordination distance is very high. It's 50 kilometers. Uh, Let me try to check this. That do we have more 50s? Okay, it's not easy to make this kind of like the distances. Generally, I see the distances are not big. 2 kilometer, 1.3 kilometer. So from this, it looks like the area is basically not very big, but it's okay. If you even if you have a small area, you can put a very big number. It's not bad. Generally, if you are want to cover a bigger area, then you should not put a smaller number. It should not be vice versa. But like we can see that the biggest link size was 8 kilometer. Uh, Otherwise, generally they are like this is 5 kilometer, but generally they are very near to each other. So it looks that the area is not a big problem. Even if he make it shorter, it will not make any big difference. So the next thing is the frequency separation. So this is one thing that I feel that it can be reduced, and reducing this may remove some of the cases. It's not that we want to just remove the cases for the sake of removal, but we don't want to exert extra energy. Why we should consider some cases which are typically not the cases. For example, if I take this as as an example right now, this victim, this has a frequency of 13050. Okay, and this has a frequency of 13075. So we can see that there's a 25 dB difference, which is fine. That's why it's showing it. But just assume for a minute, because we can see that this is very small area. I'm not sure about the area, but if just for a minute, if we assume that these are very small radios, I mean these are 7 megahertz radio only, then for 7 megahertz radio, this is reported because of only this number. If this number has been 14 megahertz, then this should not be reported, I mean. So I'm just telling it for the sake of argument that if you have really, I mean, you should put the numbers here which you really need to put. If you have most of your links are 56 megahertz, then it's well and good and fine. But if your most of your links are 14 megahertz or 28 megahertz, then you should reduce this number, and this will help you. I mean, a lot of extra cases, they should be removed. Minimum interference level has no issue, it's minus 115 is fine, but this number, it should not be 10. Generally it can be 0 as well. It depends if you are doing a frequency coordination job. If these are links from different operators, then it's fine. But if these are links from the same operator, then you don't need to put a margin. I mean, margin is generally we put margin when there are links from different operators and we want to be very strict. In the same way, you can reduce this threshold degradation to 3 dB as well if you want. If the network, because I'm saying this because of this number as well. I mean, this is showing a threshold degradation of 63 dB. This is a very high number. In my life, I have not seen this number a lot. I mean, I've seen generally very small numbers, 7, 8, 10, less than 10. I mean, usually. Greater than 10 means you have some big problems. So, like for example, this single radio, this is making a threshold degradation of 16 dB alone. I mean, which is too much. One radio is alone giving you 16 dB of threshold degradation. So this network, I think that this network needs a bigger optimization, because it has really, I mean, really big issue of frequency interference. And also this link size is very small. Now we see that this same, the like case 1 and the same case 2. Now this is only a difference of 4 megahertz. So between two sides you have two links, and one is 13050 and one is 13046, and then you have another of 13157. This may be the channel of the reverse channel maybe, but then you should have one more case, but we don't have. Okay, so this thing also needs to be checked. I mean, why we have two links with only 4 dB of difference. This link is 13046 and that link was 13050. This has a, this also because these both of these links, they should have almost similar kind of threshold degradation, because practically they are almost, I will say that these are the same numbers. I mean, if you are using a channel of 56 megahertz, then these are almost the same numbers. So these things needs to be checked. I mean, when you are checking a interference case, then you should start from these obvious kind of things, that what may be a big problem. I mean, why I have this, that I have two links with almost similar frequency channel. So what is the problem? So this needs to be checked. HRA1003 and HRA1003. So three links between the same two sides, and one link has a bigger margin of 100 megahertz and two links have only a margin of 4 megahertz. you can see that the threshold degradation of this link is also very low. I mean, if we can put this link on a frequency in middle of these two, like this is 13046, that is, this one is 13157, so this one we can put on 13100, and just by doing this and putting a right value here, whatever it is, we can reduce a lot of hopefully we can reduce a lot of interference cases. So generally the name that you have here is the victim, and these are the interferers. So this vi distance is the distance between the victim and the interferer. Then this is the interfering level, that the interferer is causing how much, what is the received level of the interference, and from this level it calculates this threshold degradation. Like for example, we can see that threshold degradation is 63.55 dB. Hopefully if you add all of these values, you will come up with the same number. Generally you should come, because this is 16 and 28, this is already 44, and then this is 18, this is already almost 62. So the remaining 0.4, 0.5, they all, when they all are added, they will be, you will get a number equivalent to this. So I hope this video, and one thing is also that you can see that there are some different type of cases. This is OH loss cases, this is a correlated cases, this is a normal case. So we have different type of interference. Some interference is called over the horizon loss, some are called correlated, and some are normal interferences. So if anyone needs to know the differences or what is this, then he can comment, I mean, because if you will comment, then you will help me in spreading the video, which will be good for me as well, and which will be good for the people who wants to learn something. So this was an interference report, and as per my understanding, it was a report between a lot of links. I mean, maybe it's a small network, and the report is calculated between all the links. Generally, we don't make reports like this because reports become very long, and you become a kind of frightened to see this much lengthy report. Generally, we make, like I showed in my video, that we take one link and then we take the interference between this link and all the other links, and that's how we correct the network one by one. So if you have any question, I mean, then you can we can discuss. And if we had a 3 dB margin, then this case may also be, in this case we should have removed two cases just by putting 3 dB as our margin, because we have very big losses. So one way is to reduce the margin. If you have a low quality network, then you should reduce the threshold degradation margin, threshold degradation as well, and you should put it on 3 dB, because having a this much bigger 33, 36 dB, 21 dB, these are quite big numbers. I mean, bigger than 20 is very big number. Less than 10 is a number that you can say that, okay, why this case is reported only 0.46 dB. This case should not have been reported by path loss. So see you in my next video. If you have any question, then you can ask. So goodbye.